I thought I'll start as usual by telling you what happened last time. Not the whole thing, but just the highlights so you can follow what's happening today. The main things I did last time were the notion of an electric field, which is going to be with you from now till the end of the course. And the idea of the electric field is that if you got lots of charges, Q1, Q2, Q3, instead of worrying about the force they exert on each other, you ask yourself, at a generic point where there's nothing, if I put 1 coulomb here, what will it experience? What force will it experience? You compute that. So in your mind, imagine a coulomb, and you find the force due to Q1 may look like that. Q2 may exert a force that way. Q3 could be of opposite sign, so maybe it'll exert a force that way. You add all these vectors, they add up to something. That something is called the electric field at that point. There is nothing there except the electric field. But it's very real because if you put something, something happens to it. Okay? So the electric field is everywhere. The charges are in a few places. Electric field is defined everywhere except right on top of the charges where probably is infinite. Once you know the electric field anywhere, if you put another charge Q, a real charge, it will experience a force equal to Q times E, because electric field was the force you would have had on 1 coulomb, and if you put Q coulombs, it will be Q times C. That's the electric field. So you can imagine computing it for any given distribution of charges, because you know what each one of them does. Then I said there's one nice way to visualize the electric field, which is to draw the field lines. You go to each point, and you ask, if I put a charge here, a positive test charge, which way will it move? Then you follow that thing as it moves, and you get that line, and you get that line, and you get that line. You can draw these lines. The lines give you one piece of information which is very obvious, namely, if you're here, the force is along that line. But I also pointed out to you, you get more than just the direction of the force. You also can understand the strength of the force. The strength of the force is contained in the density of these lines. Now, density has to be defined carefully. It's not like mass per unit volume. It's an area density. That means if you get yourself 1 square meter, meter by meter piece of wood, like a frame, and you hold it there, perpendicular to the lines, and see how many lines